So this is 3-3, which is a factoring section. It's going to be rough. All right, here's our warm-up. Our warm-up is something old, and I'm going to teach it using this special pattern here, which is a squared minus b squared now it factors. I'm also going to teach it by pulling out a common term. Now, I happen to know that I can pull a 25 from both those terms. And I know some of y'all don't believe me, but you can't fix number sense, not at junior level. But obviously 25 is divisible by 25. And I guarantee you that 225 is also divisible by 25. It should be a 9. And by golly gee wow, it is. So, minus 9. Now, x squared minus 9 is literally an x that is squared minus a 3 that is squared. So this is A and this is B. And again, I'm using this pattern over here. That's the pattern I'm using. So we have a 25 times A, which is x, plus the 3, and then x minus 3. And we're still equal to 0. And now we're going to use the zero product property. And we're going to say x plus 3 equals 0. Hopefully you can do that without actually writing it. Or x minus 3 is 0. Now if x plus 3 is 0, x is going to be negative 3. And if x minus 3 is 0, x is going to be 3. There's your two x values. I say you try if you were in class, but you're not. We're going to pull the 9. That's going to give us x squared minus 4, still equal to 0. And again, this is literally an x that is squared, take away a 2 that is squared. So I have my a value and my b value, x plus 2 and then x minus 2. Then, of course, you use ZPP. The only factors that you care about for the zero product property are the ones that have a variable x. So x plus a 2 is a 0, or x minus a 2 is a 0. So x shall be negative 2 because you're just doing shifting techniques, or adding or whatever, subtracting. And there's your two x values, negative 2 and positive 2. Moving forward. EOC practice, no calculator. This is typical EOC stuff that's on the no calculator part of the EOC. You know, we just did this one. So that one's easy. All right, so it used to be, and it's probably not the case anymore, but it used to be that they would give kids something like 64 squared minus 16 squared, and they'd say, which of the following is equivalent? What is equivalent to this? Well, hopefully the plan was that a kid would just realize that that's a difference of two squares. This is literally an 8 that is squared, take away a 4 that is squared. And we would hope that the kid would memorize a pattern. So anyways, A is 8, B is 4. And that's a choice here, choice 2. What else would this be? Not much else. I mean, this is a 4 and that's a 12, right? Which is an option. Do they have some other stuff here? Well, let's check it. This is 4 times 2 times 8, which is not what I'm looking for, because this would be 64, and this is obviously 48. So nothing else works. It's just that one. I don't know why it's a select all, but and of course there's some things here that kids would pick. Like kids would pick 3 because it turns out 64 minus 16 is 48. And kids murder the difference of two squares idea, and they choose things like choice 1. All right, here's where it gets a little rough. It's called the difference of two cubes patterns. And yeah, you kind of need to memorize it. You kind of do. You probably won't. But a cubed minus b cubed factors as a minus b times a squared plus ab plus b squared. And the piece a squared plus ab plus b squared always has two non-real solutions. So you'll notice that the instruction set here is factor and solve for real values. And it is a factor and solve. All right, that's what the technique is, factor and solve. Now, you may or may not believe me, but this is a 5x that has been cubed. And I'm taking away a 2 that has been cubed. And I know that you probably don't know your cubes, but 125, the cubic root of 125, which I can do in a TI-84 by raising it to the 1/3 power, is 5. You know, I look at the numbers and I decide, can I actually take the cubic root of them? That's what I do. And so what I've done is I've decided that A is 5x and B is 2. And I'm just going to use this pattern right here. So it's 5x minus 2, another set of parentheses. I have to take that 5x and I have to square it, plus because there's a plus. I have to find the product of 5x and 2, plus because there's a plus. I have to take by 2 and square it. And by the way, it's still equal to 0. Now we're going to clean this up to make it look right. 5x times 5x is 25x squared. 5x times 2 is 10. And then we have 4 when we square the 2. Now, the note here, this is always two non-real solutions. Now, I used to make kids find these, but then they pulled a lot of stuff from your standard, so I don't have to anymore. So I really don't want to hear you complaining about how hard this is. We used to have to do this. We would do this one, and then we would do the quadratic formula. That's how it went. That's 100% how it went. Speaking of the quadratic formula, I really need to assess you on that. But anywho, 5x minus 2 is a 0. We're going to add 2, and then we're going to divide by 5. Because we haven't done the quadratic formula in a while, have we? No, we have not. So that probably needs to be on your homework. Moving forward with our lives, we have the other pattern. It's the a cubed plus b cubed pattern. You're about to learn an acronym called SOAP. So the lettering between the two forms, whether it's plus or minus, stays the same. But the lettering itself is always the same. The S is for same. Since this was a plus, this is the same sign. The O is for opposite. Since this was a plus, this is a minus. AP, that's supposed to be a P, not a D, is always positive. That's the sum of two cubes pattern. And, you know, you've got to learn your numbers. You got to learn your cubes. Like when I see y cubed, I see a y that is cubed plus a 5 that is cubed. That's what I see. So A is y and B is 5. The light bulb that goes off on kids, I can remember all the way back to the first year I taught this, when they actually figure out how it's not that hard. It's not. We're going to take this y and square it. We're going to take away the product of y and 5, which is just 5y. And we're going to square the 5. 5 squared is 25. And remember that this is not real. Okay? The only thing I care about is the first factor. So by ZPP, y plus 5 is 0, y is a negative 5. Did I solve on the last one? Okay, I did. This one doesn't start off looking like it's anything special, but I assure you that it actually is. These are both even numbers. 16 is even, 686 is even, and they both contain a b squared. So we're actually going to pull a 2b squared. Now 16 divided by 2 is 8. We're going to have a b cubed because we pulled 2 from it, right? And 686 divided by 2 is 343. Magic, huh? Now, you know, I hope you know this, but I know kids don't. But the cubic root of 8 is 2. And the cubic root of 343, you might be surprised to know, is 7. There's my numbers, kids. So I view this again as a 2b that's cubed and a 7 that is cubed. So A is going to be 2b and B is going to be 7. And I go back to my pattern here. So we're going to leave that 2b squared out front. She doesn't go anywhere. In fact, we're going to have to use her. She's a 0. She is a real 0. And we're going to have, since we have plus, it's going to be 2b plus 7. And we're going to get to our imaginary one here again. Remember, these are all imaginary. We're going to take our 2b and we're going to square it. A 2b times a 2b is a 4b squared. Remember SOAP, next symbol is a minus because this was plus, opposite. We're going to do 2b times 7, which is 14b. And then always positive, 2b times 7, 14b. Still equal to 0. Now, there's two factors up here that I care about, the ones with the b's. So I got to use ZPP now. So by the zero product property, 2b squared is a 0, or 2b plus 7 is a 0. And then I just crank out the math, right? Like this one's so easy. But there's kids who don't get this. I divide by 2, b squared is 0. I take the square root, and by gosh, b is just 0. It's so simple. But, I don't know. Subtract the 7, divide by 2, and we get negative 7/2. There's my 2b values, my two real ones. There's also two more imaginary ones. Actually, there's three imaginary. Sorry, this one happened twice. This one happened once. There's two imaginary zeros floating around out there. And here's your acronym, SOAP. You'll notice that the lettering is always the same in these two things. It's signs that change. So you have an acronym called SOAP. Same sign. Notice a plus starts with a plus, a minus starts with a minus. Opposite. A plus, the very next one is opposite. A minus, the very next sign is opposite. AP, you put them together, always positive. Notice how the last two signs are always positive? You remember the letters. You think about SOAP for the signs. Of course, I just always remember plus, minus, plus, and minus, plus, plus. But my brain works differently. All right, select all the following, which is equivalent to 8x cubed minus 64. This is a select all. Now, there's multiple ways of factoring 8x cubed minus 64. One of the things you can do is you can pull an 8. And then you can see this as an x that's cubed, take away a 2 that's cubed. And then you can hit it with that special property. This is a difference of two cubes. X minus 2, square that piece, plus because it's opposite, 2 times x, 2x, plus because it's always positive, 2 squared is 4. That should be an option. Right there she is. All right, now, you could have gone back to the original problem, which was 8x cubed minus 64, and you could have actually looked at it like this. It could have been a 2x that's cubed minus a 4 that's cubed. We're looking for equivalent functions here. And now a is 2x and b is 4. They might look different, but I promise you they're the same numerically. All right, so where am I at? A is 2x. So I'm going to have a 2x minus a 4. I'm going to square 2x and get 4x squared. I'm going to add the product of 2x and 4, which is 8x. I'm going to add a 4 squared, which is 16. And there is my other one. Now, they actually wrote this one a little bit different. Plus, plus, choice 3. See that? That made that one wrong. That's a very good distractor. And nothing else up here works. Nothing else up here works. And to be quite honest with you, knowing signs, look at this, minus, plus, plus, minus, plus, plus, minus, plus, plus. That one was gone from the get-go right there, wasn't it? Wrong signs. And these are just nonsense answers that kids pick over and over and over and over. I'll pause and I'll be right back. I want to see how long I am right now. Oh, that's not bad. So factoring by grouping as algebra 2 is always one of these things that blows my mind that kids don't remember, because I know that it was taught to you in algebra 1. In fact, you were taught how to factor trinomials using a grouping technique. So I'm always surprised that kids don't remember it. But what we do is we just focus on the front and the back somewhat separately. And we think about what we can pull. All right, so if I look at x cubed minus 3x squared, I realize that I can pull an x squared from both pieces because they both possess it. And if I do that, I'm going to have x minus 3 left over. Now, the goal of factoring by grouping is that this factor would repeat. That's the idea. Now, I happen to know that both of these pieces are divisible by 16, and if I pull the negative 16, that would make the x positive and the 48 become negative. Now think about what you wrote. Negative 16 times x is negative 16x. Negative 16 times negative 3 is positive 48. And this is going to seem really funny, me saying this, But you have gone from something with 4 pieces into something with 2 pieces. This is one thing and this is one thing. And both of them have a common factor of x minus 3. If I pull x minus 3 from the first piece, what's left over is an x squared. Boy, that looked like a bad 2. Still a bad 2. If I pull x minus 3 from the second piece, what's left over is the negative 16. By the way, still equal to 0. But wait, there's more. There's always more in math. How's that factor? That's a difference of 2 squares patterns. It's a minus 4 and a plus 4. Now you can use ZPP. So by ZPP, that one would say x is 3. That one would say negative 4. Sorry, positive 4. This one would say negative 4. Apparently I haven't woke up just yet. That's factoring by grouping, kids. Now there's another one on here. It actually has a glitch in it, some to say. It's not in standard form now, is it? Is this one in standard form? No, it's not. Solving requires us to use zero product property usually, which means we're going to be set equal to 0. So we're going to take this bad boy. We're going to shift that 36 to the left, and that'll make it positive. And now we're going to attempt to factor. And again, we're going to focus on these pieces, all right? Both of them are divisible by 5, and they both contain a b squared. So I have a 5b squared. If I pull that from 5b cubed, there is a b left over. If I pull it from 15b squared, there is a positive 3 left over. And remember, the goal in factoring by grouping is a repetition of that piece, because we want it to be common to 2 things. Now, it turns out if you pull a 12, you're in business. That's got to be a positive here, by the way, because 12 times b is 12b, and 12 times 3 is 36. Again, what these 2 pieces have in common is b plus 3. The stuff that's left over is 5b squared plus 12, all equal to 0. That's supposed to be a 3. Now, by ZPP, b plus 3 is 0, so b is negative 3. And this guy right here, we'll go ahead and start it off. We're going to set it equal to 0. We're going to subtract our 12. We're going to divide out our 5. And then we're going to take the square root. It'd be plus or minus the square root of a negative 12/5, which is not real. It's not a real thing. You can't take the square root. You can't take the even root of a negative number. It's imaginary. And the last one, word problems. Suppose you have 250 cubic inches of clay with which to make a sculpture of a rectangular prism. You want the height and width to each be 5 inches less than the length. What should the dimensions of the prism be? So the height and the width are each 5 inches less than the length. So the width would simply be the length minus 5, and the height would simply be the length minus 5. So that's what's there. The length is L, the height is L minus 5, and the width is L minus 5. The setup here is that volume is length, width, height. All right? Length times width times height, and it has to equal 250 cubic inches. Next thing we would do here is we would probably foil this piece, or you could box it out. You could do a box, it's up to you. But if you do L minus 5 times L minus 5, you get L times L squared minus 10L plus 25. Then we would distribute that L in. That would give us L cubed minus, it looks like LOL, but it's minus 10L squared plus 25L equals 250. We would shift that 250 to the left to get a 0 on the right-hand side. This does factor. If you look at these first 2 pieces, they both contain an L squared. And if you pull an L squared, you're going to have L squared times L minus 10. And if you pull a 25 from both pieces on the end of it here, you can have 25 times L minus 10. So the common factor is going to be L minus 10, and then you're also going to have L squared plus 25. The solution is done by the zero product property. Length is 10, and if we plug it in, 10 minus 5 gives us a width and a height of 5. There you go. That is 3-3 factoring. Oh, it's going to be wonderful.